The height, h meters, of a projectile above the ground at time t seconds after the launch is given by the quadratic function h of t is equal to negative 4.9 t squared plus 16t plus 2. So we have to write a quadratic equation, which can be solved to determine the time it takes for the projectile to hit the ground. Here's the keywords: hit the ground, and the height is in meters, right? And that's going to affect this part right here. Essentially, all we need to do is replace h of t with 0. So it's going to be 0 is equal to negative 4.9 t squared plus 16t plus 2. Algebraically determine to the nearest tenth of a second the time it takes for the projectile to hit the ground. In that case, what you're going to do is you're going to use the quadratic formula. A in this case is going to be negative 4.9, B is going to be 16, and C is going to equal 2. So when you punch that into your quadratic formula, this is what it's going to look like. X is equal to negative, and in brackets it's going to be 16, plus or minus 16 squared minus 4 times negative 4.9 times 2 all over 2 times negative 4.9. If you've worked it out properly, it should look like this. It should be negative 16 plus or minus the square root of 295.2 all over negative 9.8. Now what you're going to get for an answer, don't forget, of course, you're going to split this apart. You have the plus and the minus. You're going to have negative 0.12 and 3.14. The question is, which one is the correct one? Well, the time it takes for the projectile to hit the ground, this is negative. You can't have negative time. So this will be your answer. It's going to be about 3.4 seconds.